Welcome back everyone. In today's session we are going to see few interesting things about pair of linear equations in two variables, that is, how many solutions does pair of linear equations have, and when you draw the graph of pair of linear equations, okay, how will be their graphs, and consistencies, inconsistencies. These three things we are going to see in this session. So previously we have done many equations in which we were getting one solution for pair of linear equations, a unique solution we were getting. Okay. So do you think every pair of linear equation have a unique solution? Does every pair of linear equation get a solution? Let's see an example now. So you can see one example here. Solve for x and y by using elimination method. So we have done many questions. I gave you a lot of practice for this concept. Now let's see a question here. You can just have a look at this question. Here, if I eliminate by addition, so what can I eliminate? I can eliminate 3y minus 3y, okay, plus 3 minus 3 becomes 0. Then 2 minus 2 also gets eliminated here. So nothing remains, there is no variable remaining. Got it? And 5 plus 7 is 12. So whose value will you find if there is no variable remaining in the question? So this type of cases are said to have no solution. Okay, so pair of linear equations may not have a solution also for this type of cases. Okay, so then let's see another question. Case 3, 3x plus 2y is equal to 2. You can see equation 1, and 6x plus 4y is equals to 4. Okay, if you try to solve it by elimination method, so suppose if I want to cancel y, so what do? We make this 2 as 4, so I can multiply 2 on both the sides. Yeah, I can multiply 2 on both the sides of the equation. So what happens? This becomes 6x, this becomes 4y, and this becomes 4. Okay, so finally you can see here these two equations are nothing but same. When you try to eliminate them, eliminate anything by subtraction, so what happens here? Everything gets cancelled. 4y minus 4y, 6x minus 6x. So these two equations are nothing but they are same equations. Okay, these two equations are same. Just when you divide the second equation by 2, you will get the first. Divide the second equation by 2, 6x by 2 plus 4y by 2 is equal to 4 by 2. What will you get? You will get 3x, you will get 2y, and you will get 4 by 2 is 2. So there is no difference between these two equations. It's a single equation. Okay, when you take it common, so we will take it as a single equation, not as a pair. So how many solutions a single equation has? Single linear equation in two variables, it has infinite solutions, which we have done in 9th class. Okay, so this type of equations are said to have infinite solutions. So basically we have three types of solutions for pair of linear equations. One is a unique solution, which we have done in the previous sessions, and you have also solved a worksheet on that. You are getting a unique solution, and there will be no solution also. Like this case, there will be some pair of linear equations which has no solution also, and there will be some pair of equations which has infinite solutions, like this. Okay, So keep these three things in your mind. Now let's see one example of unique solution. Now without solving the pair of linear equations, we can we can say whether they have a unique solution or no solution or infinite solutions. Okay, so if pair of linear equations are given to you and without solving, by comparing the ratios, if you want to say how many solutions it has or whether it is consistent or inconsistent. Now what do you mean by consistent? Consistent is the equations which can be solved and the equations which have a solution. So I can say the unique solution, when you get unique solution you can say it is consistent. Infinite solutions is also consistent, whereas no solution is called inconsistent. Got everyone? So we have seen number of solutions, how many solutions pair of linear equations can have. It can have a unique, or it can have no solution, or it may have infinite solution. Then consistency is the first and the third, these two are consistent, and the second, that is no solution. When there is no solution we say inconsistent because it cannot be simplified. So let's see by using the ratios, by comparing the ratios of the coefficients, we can say whether the equations have unique solution or not. So these are the two equations given to us in the question. 3x plus 2y, I'll bring that 5 to the left to make it in standard form, and 7 to the left, it will become 2x minus 3y minus 7. So I said you in the beginning of the chapter, the general form of pair of linear equations is a1x plus b1y plus c1, and this is the general form of pair of linear a1x plus b1y plus c1, a2x plus b2y plus c2. So I'll compare the first equation with this and the second equation with this. So if I compare, let's see what will be our a1 b1 c1 and a2 b2 and c2 values. So a1 will be the coefficient of x. What is coefficient of x? 3. b1 will be coefficient of y, that is 2, and c1 will be the constant, that is minus 5. Similarly, we'll find a2 b2 and c2 values because this is the second equation. So what is coefficient of x here? a2, that is 2, then b2 is minus 3 and c2 is minus 7. So this way first we will find the coefficients, okay, and I'll write all of them here. Then we'll find the ratio, okay, ratio of a1 by a2, b1 by b2 and c1 by c2. Now see, very interesting thing here. By looking at the ratio we can say how many solutions does this equation has. So what is a1 by a2 here? a1 by a2 is 3 upon 2, that is 3 by 2. Then b1 by b2 is 2 by minus 3, that is minus 2 by 3 you can say. And now looking at these two values, will not go to c1 by c2, okay. First you should see at this, look at these two values, a1 by a2 and b1 by b2. Are these two values equal? Here I am getting 3 by 2 and here I am getting 3 by 2 and here I am getting minus 2 by 3. Are they equal? No. So since a1 by a2 is not equal to b1 by b2, we can directly say that this type of equations, these equations has a unique solution. How many solutions does it have? Unique, and our system is consistent because we can find the solution. And when you draw the graph of this type of equations, like you have learned in 9th class how to draw the graphs. So when you draw the graph of this type of equations, you will get intersecting lines. How will be the lines? Intersecting lines. For one solution this point of intersection, wherever this lines meet, that is called point of intersection, and that will be your solution. So you remember in 9th class we have done so many graphs. We find 3 solutions of each equation and plot them on the graph. So when you plot these 2 equations on the graph, when you plot on the graph, you will get intersecting lines. How will be the lines? Intersecting lines, okay? And that common point of intersection is the solution, okay? So if remember this first case, if a1 by a2 is not equal to b1 by b2, suppose if a1 by a2 is equal to b1 by b2, then let's see what happens. Let's take another example here. You can see this example: 2x minus 3y minus 8, 4x minus 6y minus 9. So again we'll compare it and we'll get the values of a1, b1, c1, a2, b2 and c2. So we'll find the ratios. So we have taken the values here. a1 by a2 is 2 by 4, that is 1 by 2. b1 by b2 is also 1 by 2. Now a1 by a2 and b1 by b2 are equal. Then we will go to c1 by c2. Okay, c1 by c2 is 8 by 9. So when this condition exists, a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, then we say that this type of equations have no solution and they are inconsistent. And when you draw the graph of this type of equations, you will get parallel lines. Okay, for first case we will get intersecting lines. For second case, that is no solution, parallel lines, because parallel lines they never meet, so there is no solution to that. Okay, so this is the second case. If a1 by a2 is equal to b1 by b2, then you should find c1 by c2 also. If a1 by a2 is not equal to b1 by b2, then you should not go for c1 by c2. Like in the previous case, a1 by a2 was not equal to b1 by b2 here, 3 by 2 minus 2 by 3. So we did not go for c1 by c2. It's of no use even if you go. So looking at these two values, when they are not equal, we said unique. And for this one, looking at all these three, because these two are equal and this is not equal, so we said that this type of equations have no solution. So hope you remember the example which I showed you in the beginning, that the pair of linear equations can have a solution or it may not have a solution also. So this is the way to check, and it is called inconsistent. Let's go. What is the third case? Infinite solutions. So again the pair of linear equations are given. Let's compare the ratios, compare the coefficients. Here if I compare, a1 is 5, b1 is minus 3 and c1 is minus 11, and a2 is minus 10, b2 is 6 and c2 is 22. We'll find the ratio again here, a1 by a2, b1 by b2. So let's see what is a1 by a2 here. a1 by a2 is 5 by minus 10 minus 1 by 2, b1 by b2 is minus 3 by 6, that is also minus 1 by 2. These two are equal, and let's see c1 by c2, that is also equal to minus 1 by 2. It's amazing. So all the three are equal in this, all three ratios are equal. So when this condition exists, we say that this type of equations have infinitely many solutions, because these both are nothing but one equation and our system is consistent. When you draw the graph of this, how will be the graph? The lines will be coincident lines. How will be the lines? Because both the equations are same. How they are same? Let's see once more. Just divide this second equation by 2. What happens? If you divide the second equation by 2, by minus 2, because minus is there here, so you'll get minus 10 by minus 2, 5, then minus 3, 6 by 2 is minus 3, 22 by 2 is 11. Okay, so these two equations are said to have infinite many solutions. So these are the three different ways which we can have in pair of linear equations: unique solution, infinite many solutions, and no solution. For unique solution, graph will be intersecting lines. This is for unique, this is for no solution, and this is for infinitely many solutions, and these lines are called coincident lines. What do we call these lines? Here you can see only single line, but actually there are two lines. Coincident means line above another line. One line is there, then again one more line on the same. They are called coincident lines.